Section 3, proving similar triangles. So there's 3 ways to show that triangles are similar. The first way is angle-angle. To show 2 triangles are similar, it is sufficient to show that 2 angles of one triangle are congruent or equal in length in measure. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. So obviously, if this angle is congruent to this angle and this angle is congruent to this angle, we even know by the third angles theorem back from the beginning of the year that this third angle must be congruent to this third angle, because no matter what the size of the triangle, they have to add up to 180. So that's why 2 angles are sufficient enough to show that 2 triangles are similar. And we would just write angle-angle for our proof statement, and that's enough to prove that the triangles are similar. The second method is side, 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 but be careful because this is not the same theorem that we use for congruent triangles. To show triangles are similar, it's sufficient to show that the 3 sets of corresponding sides are in proportion. So they're not congruent, they're in proportion. So if the 3 sets of the corresponding sides of the 2 triangles are in proportion, then the triangles are similar. So if AB is in proportion to DE, if AC is in proportion to DF, and if BC is in proportion to EF, the triangle ABC is similar to triangle DEF by side, 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 similar to side, side, side. The final method to prove 2 triangles similar is side, angle, side, but again be careful because this isn't the same theorem we used for congruent triangles. To show that triangles are similar, it's sufficient to show that 2 sets of corresponding sides are in proportion and the angle in between those 2 sides are congruent. So if an angle of one triangle is congruent to the corresponding angle of the other triangle, so here and here, and the lengths of the sides including these angles, so that form that angle, are in proportion, then the triangles are similar. So if A is congruent to D, and AB is in proportion to DE, and AC is in proportion to DF, and that proportion is equal, obviously it has to be by that scale factor, by that common ratio, then triangle ABC is similar to triangle DEF by side, angle, side, similar to side, angle, side. So a line is parallel to one side of a triangle and intersects the other 2 sides if and only if the points of intersection divide the sides proportionally. So this is a little bit different. We've talked about medians of triangles before. This isn't the median of a triangle. But if DE is parallel to AC and it intersects AB and BC, that means it divides the sides proportionally. Okay? So that means that BD, the measure of BD over the measure of DA, is equal to the measure of BE over the measure of EC. So they're in proportion to each other. Now, if I told you that the 2 triangles were similar, the smaller triangle and the bigger triangle, you could say, given angle-angle, that these 2 triangles have this angle congruent and this angle congruent, if I told you that they were similar. But either way, what this theorem tells us is that if this line is parallel to the base of the triangle and it intersects the other 2 sides, it intersects the other 2 sides so that it cuts it into proportions. Now from this, we could also say that BD is in proportion to BA and BE is in proportion to BC because it's cutting it into proportional pieces. So that means the whole piece, we could also say that this is in proportion to the whole, this is in proportion to the whole. And then by the reflexive property, this angle would be congruent to itself, and you could prove the small triangle similar to the big triangle by side, angle, side, similar to side, angle, side. Now here we have our first example. So given that AE is a line, that DB is a line, and that AB is parallel to DE, we want to prove that DC over BC is in proportion to DE over BA. So our first step is just going to be the given statements. Our second step can be that angle D is congruent to angle B, and angle A is congruent to angle E, because if two parallel lines are cut by a transversal, the alternate interior angles are congruent. You could have also used that angle DCE is congruent to angle ACB because intersecting lines form congruent vertical angles. That's another possibility. Either way, we just showed that triangle DEC is similar to triangle BAC by angle-angle similarity theorem. And you can just write this. You don't have to explain if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. You can just write angle-angle similarity theorem. Therefore, if the two triangles are similar, that means that DC over BC is equal to DE over BA, and when we prove triangles congruent, we said CP/CTC, but now we have similarity, so we say corresponding sides of similar triangles are in proportion. Here we have the given statements. Triangle ABC is isosceles, and the base is AC, which is important to know so we know which sides to say are congruent or which angles to say are congruent. And angle 1 and angle 2 are right angles. So this is a right angle and this is a right angle. Our first statement is just going to be the givens. Now our second statement is going to be that angle 1 is congruent to angle 2 because all right angles are congruent. Now we're trying to show that AE over BD is in proportion to CE over DC. So we're looking at triangles BDC and CEA. Well, we can say that AB is congruent to CB because an isosceles triangle has two congruent sides, or legs. And that means that angle BAC is congruent to angle BCA because if two sides of a triangle are congruent, then the angles opposite them are congruent. That means that triangle AEC is similar to triangle CDB. Again, you can just say by the angle-angle similarity theorem. You don't have to explain the whole method, but by the angle-angle similarity theorem, which means that the sides are in proportion. So AE over DC is equal to CE over BD, and that's because corresponding sides of similar triangles are in proportion. And finally, we want to prove this, that AE times BD equals CE times DC. Well, in order to do that, if it's a proportion, isn't it true that we can just cross multiply? Therefore, our last statement is that AE times BD equals CE times DC, because in a proportion, the product of the means equals the product of the extremes. Make sure you use this terminology. The product of the means equals the product of the extremes in a proportion. Therefore, that statement is true. And that would be the end of your proof. I want you to copy down this proof and try it. You can use the numerical values and substitution to show that they're in proportion when you reduce them down, so just as a clue. So copy this down, try it. This is part of your homework, and we'll go over the answer in class. I also want you to try this proof. You're told that two isosceles triangles are similar if the vertex angle of one triangle is congruent to the vertex angle of the other triangle. So these are your given statements if you want to copy them down. And you are trying to prove that the two triangles are similar. Finish these up and we'll go over them in class. Make sure you submit a picture of these two proofs with the video.